Hello again, ladies and gentlemen. We are going to be kicking off Talk Room 1. Talk Room 2 and 3 are lining up and should be starting momentarily. As you'll have noticed, we're 5 minutes behind schedule. Like we did yesterday, we'll try and make that up at tea if we can. Right. Next talk in Talk Room 1 this morning is Stefan Van der Merwe, who I realized we had a slight confusion because we also have a Stefan Van der Merwe who's actually here as well, and we realized we messed up the gift bags because we thought they were the same person. Empowering snake charmers in training is what Stefan is going to tell us about. I realized I was remiss, my apologies, I didn't read a bio for Max this morning. I can do one better for his colleague and read an actual bio for the man. My apologies, Max, that was rude of me. Okay, yeah. Well, as I was going to say, I was going to read Stefan's bio. It won't take me long. Electronic engineer by training, software engineer by job title, and open source software geek by all other standards. I like that. I might borrow that. That effectively describes me. I like it. Thank you, Stefan.
Thank you, Kim. All right. Thanks for the opportunity, guys, and welcome here. So today I want to talk to you about empowering snake charmers in training. So what is a snake charmer in training? It's somebody that wants to learn Python or is learning Python but is not a Pythonista yet. We will get them there. So just a little bit of an ego trip first. Who am I? My name's Stefan Van der Merwe. I am an electronic engineer by training, as you've heard, software engineer by title, and my greatest passion in life, apart from food and Python, is to empower people. So whenever I find myself in a place where I can use my skill sets to do that, that's when I'm at my very happiest. So I work with my colleague Max at a company by the name of Ex Mente Technologies. Ex Mente is Latin for from the mind. We like to think about things, and if you've heard Max's talk, you know that we like things that burn. Some people say we are out of our minds just because of the way that we do things and some of the ideas that we have. We are a pyrometallurgical consulting company focusing on thermochemistry and multiphysics modeling. Now that's a mouthful. What it comes down to is we've got a set of process engineers in our team that consist mainly of metallurgical or chemical engineers that like to think about the chemical interactions happening inside a furnace when you melt down ore to find an ore to get an alloy afterwards. Our multiphysics modeling team are mainly, well, solely mechanical engineers at this point in time, which like to think about the physics, what's actually happening on a physical level inside that furnace when we start melting things. We believe at Ex Mente that mining and mineral industry in South Africa holds the key to the advancement of our society. And we like to help our clients to extract clarity from complexity and to advance them through insight. Right, so how do we use Python in Ex Mente? What's the role of Python at our company? You will see in 2017, Johan Zitzman, our CEO and founder, did a talk at PyConZA about mixing metals with snakes, particularly how we apply Python in thermochemistry. Some of the tools that we wrote, some of the tools that we use that other people wrote, to make it a lot easier to do calculations and to gain insight from data. Rather than sitting and manipulating Excel spreadsheets all day, we want our engineers to be able to effectively use their time to sit and think about the problem and apply their minds to the problem rather than just manipulating raw data. One of the tools that we use that is very powerful in that regard is ChemApp for Python by a company called GTD Technologies in Germany, which effectively brings the power of ChemApp, the tool that they developed, to Python. We then went and expanded on this with an internal tool that we call Ex Mente Thermo or EM Thermo, that enables us to more easily use chem app calculations on big sets of data and to run a lot of simulations, store the results in a MongoDB database, read it from there, and then easily graph the data so that you can gain insight visually from what you are doing. Now, we know when we let Python loose, it can become quite destructive. With that in mind, we have to keep it in a contained environment. So we try to empower our engineers by giving them a contained environment in either Anaconda or pip environment. Those are the two main environments that we use, virtual environments, which enable us to have complete environmental control. What does this mean? We can control what version of Python is in that virtual environment. We can control what packages are available to the engineers. Most of the time they will set this up themselves, and it allows for separation between projects where you can use a very specific version of EMThermo and ChemApp combination with a very specific version of your own scripts running on a specific version of Python, separate for each and every project. It becomes reproducible. We do have cases where our clients will come back to us in 3 to 5 years' time and say, listen, you did a calculation for us, you did a recipe, and we just want you to change one or two things about it. Am I still live? Can you hear me? Oh, okay. Can you guys still hear me on the, okay. So they will come back to us and say, listen, we've got something changing in our plant. Can you please apply this change to the recipe, see what the expected results will be? It also makes our environments transferable. Sometimes we want to be able to run that calculation on a process engineer's local laptop, and we want to be able to push it to a calculation server running a workload manager, in our case Slurm, which we can then spin up the virtual environment and run a lot of data sets over a long period of time, not worrying about stuff like having your laptop plugged in or connected to the database. So apart from Python, we use a variety of different technologies at Ex Mente. It includes, but is not limited to, LaTeX, Subversion, and Get. All this is to say that our engineers are quite comfortable in the terminal with command line CLI apps, command line interactive apps. We tend to use a KDE-based desktop environment. In our case, at the moment, we use Kubuntu, which has Dolphin as its default file explorer. Dolphin enables us to quite easily have a terminal at our fingertips whenever we have somebody that's browsing through their computer. Whenever you open up a folder in your file explorer, you can have a terminal at your fingertips, which means a CLI app is not far away. It's very close at any moment. So the role of CLI apps in Ex Mente is generally to help us with repetitive, mundane tasks. How can we automate this? How can we give something to an engineer that he can run in his terminal that does things for him so that he does not manually have to copy, paste, or manually have to enter the commands, stringed commands, to run a build or a build recipe for LaTeX, as LaTeX is our dominant documentation format. It also means that CLI apps are a very easy and cheap way for us to put power into our engineers' hands, since all of them are comfortable with it. The goal is not for our software team, which at this point in time only consists of 2 engineers out of the 16 working at our company. The goal is not for us to write and develop all of the tools for our engineers. We want to empower them. We want them to be able to write their own command line interactive apps, and we want them to do it in a tool that they use regularly. So with that in mind, I would like to take a look at a specific example and then use it to frame a story and tell you the story of my personal journey deciding and moving towards the technology that we use inside our company for this specific goal. The exact example that we're looking at is to create a new report from a template. So Max and our CEO Johan has developed a extensive LaTeX documentation infrastructure. It's really powerful piece of tool, but you need to build it from a template. You can't start from a raw file. It's not that simple. Usually, we would just copy and paste the folder structure of a report into the folder, into the directory that we want to work on the report with, or that our project is built in. An easier way to do that is to simply go through the terminal. We are in the terminal at this point in time. We have it available. Okay, I'll get to the warning now. Let's go ahead. We have a terminal at our fingertips with Dolphin, and it's quite easy to open up a terminal on any Linux system. Before I continue, I'll just give the disclaimer. Please note that a lot of this that's coming is my personal opinion. I am aware that there are quite a few, actually a lot more systems available to do this in Python and in many other open source languages. This is just my personal journey getting there. All right, so as I mentioned, the quite quickest way to get to it is simply use the terminal that's available. You will just run a cp or a copy command, remembering somewhere a very long path where you stored your set of templates, keeping it in sync with the server, and then copying the template that you want. And it can become quite messy. If you just hit tab complete, it shows you all of the different templates available. Copying that template towards or into the directory that you are working with. We want to make it a little bit easier. So enters bash. Bash scripting allows us to then run all of the commands that we would usually run in a script with arguments. Big problem with bash that I've started experiencing is that it can become quite a hassle to debug, and it can become quite very large, a very large file to develop and to write if you want to perform just the simplest of tasks. This is just an example script. As you can see, we've only got the help on the screen. On the right-hand side, you can see the code overview. This is an extremely simple script that I wrote earlier this year just to automate our TechLive installation on our systems. Okay, let's get to Python. I realized that I can either have all of our engineers learning to write and debug bash scripts, or I can use a tool that they already have in their toolbox. So let's use Python. It's something that they use almost every single day. The simplest way, easiest way, when you quickly do a Google search, how do I get an argument into my Python script? sys.argv. Now, if we want to, just for the sake of our little talk here, access two variables or arguments. The first being the name of the template, the second being the destination folder that we want that template to initialize our document in. And we want it to have the template as a positional required argument and the destination as an optional argument. You can see that we have to work with an if-else statement capturing those variables or those arguments. This if-else statement block can become quite a hassle to manage if you start getting into more complex applications requiring a lot more arguments to be input into your application or into your terminal during application calling. So how do we handle more complex configurations? Well, we use a library that tells you what it wants. When you're in the terminal and you use argparse in your Python application, you can enter the -- help tag onto your app, and it will provide back you with some feedback as to how to use the application and what options are available, what arguments and options are available. All right. So if we define a argparse app, simple app, we first need to create a parser. That parser object, then we need to attach to it the arguments that we want. The first one being our template, and we tell it what type it has to be, and it will do that type verification for us. There's no need for us then to do a assert statement in our code to ensure that that argument or that argument value is in the correct format. We can also include a little handy dandy help tip so that when you run the help command on your app, it shows you what that argument is for. Now when we do the same for an option, we just include the -- in front of the argument, and that will then become an optional parameter not required to run your application. At this point in time, I thought to myself, there has to be a simpler way. There has to be a simpler way to do this than through either sys.argv or argparse. Enters click. Well, normally people would just want to click on it, but this is not that kind of click. Command line interface creation kit is a wonderful way to create command line apps in Python. The first thing that we have to do is we create a function. So we'll just define our function being start document right here. The function will then have all of the arguments that you want to be available in your command line as arguments with the type specified. And we'll just call that function and run it. Now, at this point in time, it's not a command line or a click app yet. Click uses function decorators to create the command line interface. The first thing that we'll add is the click command decorator. At this point in time, you've got a functioning command line interactive app. However, we want one of the arguments to be required positional and the other one to be an option. For the required argument, we'll simply add the click.argument decorator with the name of the argument. And then for the option, we'll add in once again that -- indicating that it is an option, and we'll give it a default value and a help string. At this point in time, I once again found myself saying, okay, this is a lot easier, it works, but there has to be something better. And that's when I found Typer. Now, Typer is a wrapper around click, and it makes it a lot more accessible for people that are really new into Python and into creating command line apps. For reference, this will produce mostly the exact same result as a click app. We don't have a single decorator on our function. We simply call our function by the typer.run command. Typer will then automatically extract the arguments, and since we've already given a default value for our destination, it will see that that's an optional argument. But what if we want to add a help string to those arguments? We can simply use the typer.argument and typer.option classes or functions in our as the default values to our argument. Now, when I take a look at this block of code, it's a lot more simpler and cleaner for me personally to read than it is to read a block of code with a lot of decorators in it. It also empowers us to add a help string on the required positional arguments, which is a little bit more difficult to do through click. But wait, there's more. So since Typer is standing on the shoulders of the giant that is Click, we can now introduce nested commands in a very simple manner. So what is a nested command? A nested command firstly allows you to include multiple commands in a single Python script or Python application, and then you can group them together to create a subset of commands underneath one. A good example of this would be the get CLI tool, where you can say get add and then something follows, or get config, which is probably a better example of that, where you have config as your command, and then following that is a set of subcommands. What do you want to configure? This is just an example of having two commands in a simple Typer app. The first thing that we'll do is we'll create a Typer object or application object, and now we start using decorators. We add a simple decorator called command, and in this we have used the name that we want that command to be in the command line interface app. The second one is simple. We just added a start project. Same thing. We can add that app.command decorator to numerous functions, and then we have a set of commands in our Python application. Now, who said command line applications have to be ugly? There are pretty ones, and I am aware of that. So I'll tell you a little bit about them. This is Click. Click really does, when you enter the help command on your app, does make it a lot more easy to read what your application does, rather than having to go back to your script and opening it up again every time to remember, oh, I have to have 3 positional arguments, or what the options are. Okay, this works, but it can be better. And here we get to Typer. Typer introduces the rich, or uses the rich package to turn your terminal into a colorized and quite frankly a easy pleasing on the eye application. So just colorizing and regrouping your arguments, it makes it a lot easier to read what your application is doing for you, or is able to do for you. So over here I've just placed the two next to each other. This is the exact same application, just in Click on the left hand side and Typer on the right hand side. In summary, there are some pros and cons to each step. Using sys.argv and argparse means that we do not have any external dependencies. We can build a sys.argv or a argparse application from purely Python libraries. There's no need to import anything, no need to install anything. Well, you have to import, you don't have to install anything. It can become very cumbersome, and it's not always straightforward how you should do something. Click, on the other hand, is very highly configurable, and it has good documentation. It's a lot easier to develop in, but sometimes it feels to me that it's got way too many steps to configure just to get a simple application up and running. Typer is very user and developer friendly. The one thing that I do find that it's lacking in is documentation. I think it's because they tend to rely on you understanding that when you want to start doing advanced things in Typer, you have to refer back to Click since it's built on top of Click. Now you have a dilemma. How do you choose which one you want to use? The first thing that I would consider is your external dependencies. If you run in an environment where you are not able to install any third-party dependency libraries, I would say stick to argparse. That would be mostly your best bet. If you are looking for a good developer experience, but you are not worried too wildly about how pretty things are, and you want, if your developers are experienced themselves and they want to start doing more advanced things, I would suggest that you go with Click. If user experience becomes really important to you and you want something to look pretty and just work nicely, I would consider Typer. It's also a lot easier to start using Typer when you have an inexperienced Python developer that wants to create a command line app. So that was a very short and sweet talk, but that's me. Thank you very much.
Well, fantastic. Thank you. Thank you, Stefan. I must say, in the few minutes you spoke Typer, you sold me on Typer. I've got as far as using Click, and I was happy with Click, but now looking at Typer, I think that does everything I don't like about Click. Brilliant.
Yeah, that's the one thing that really caught me.
Perfect. Thank you. I also did, as you were mentioning earlier, it occurred to me, it's too late now, but I should have arranged an understatement of the conference award, because the statement, it can be challenging to debug Bash, could be unpacked for some hours with some experience of all of us thinking, oh, yes. Do we have any questions? Anybody got anything for Stefan? Hanses? I've taken my glasses off, but I'm just to see hands. There we go.
Is there anything better than Typer?
I believe so.
Yeah, we need progression.
I believe so. I believe so. So I am aware of something, I believe it's called Termux, where you can create almost like a full-on visual application with Windows in your terminal. It's not something that I've used before, but it's something that I'll probably have to use at some point in future. So definitely, I believe there are things that are better. If you are looking for something that's quick and easy to put together and just does the job, I'd stick to Typer. Johan?
Something that you mentioned just in passing about older environments, I would suggest that you look at installing the virtual env and keeping that around.
Yes.
I have found packages disappearing off PyP, especially Python 2.7 packages.
That's interesting. It's something that we haven't seen before.
They've deprecated Python 2.7, and I had some stuff that was still running on the old things. Had to go and hack the virtual env to get the actual packages back. Be aware of that.
Thank you for that tip.
If I could just comment on that, and it's not actually what we're speaking about, but just as a side note, what I've inadvertently done, which inadvertently fixed exactly that problem, is running my own local PyPI at work. There's several packages you can get. I think I'm running devpy, which isn't particularly complicated. All it's literally doing is pass through caching of Python packages. But it means that if it's not available on the Python side anymore, but it pulled it down before, you've still got it. Until you clean it up accidentally, which I've never done. No. Any further questions for Stefan? Otherwise, yeah, I was just going to point out, as I think I mentioned yesterday, or I might have mentioned it here, or otherwise, this kind of thing, that the CLI stuff, if you can get into it, it's really super powerful. My users are very, very lucky to get a CLI out of me at all. They're certainly not getting a GUI. So that the typer and the colors and the stuff. And the one thing I was just going to mention, if you don't want to go past Click to Typer, although I'm sold, there is also a package that'll do rich color for Click. You can get a rich Click, which will basically make your Click output colorful and pleasant and nice and so forth.
Yes.
Other than that, I think thank you very much, Stefan. That was fantastic.
Thanks, guys.